Robotics has become increasingly vital in our modern world, playing a crucial role in various aspects of our daily lives. It is transforming industries and reshaping our lives in ways we could have only imagined a few decades ago. From automated manufacturing processes to sophisticated surgical tools, robots are enhancing efficiency and precision across various sectors, making tasks faster and more accurate. They offer solutions to complex problems and push the boundaries of human capability, enabling us to achieve feats that were once thought impossible. Robots are revolutionizing how we work, live, and interact with our environment, seamlessly integrating into various aspects of our daily routines. They are taking on tasks that are dangerous, repetitive, or require extreme precision, ensuring safety and consistency in operations. This allows humans to focus on more creative and strategic endeavors, fostering innovation and progress in numerous fields. The impact of robotics is felt across various fields, from healthcare and manufacturing to environmental protection and space exploration, demonstrating their versatility and importance. The development of robotics has opened up new possibilities for exploration and innovation, driving advancements in technology and science. Robots are assisting scientists in uncovering the secrets of the deep sea and exploring distant planets, expanding our understanding of the universe. They are also being used to develop new materials and technologies that can address global challenges such as climate change and resource scarcity. The future of robotics promises even more exciting advancements that will further transform our world, making it more efficient and interconnected. As robots become more sophisticated and integrated into our lives, it is essential to consider the ethical and societal implications of their widespread adoption, ensuring responsible use. This includes issues related to job displacement, privacy, and the potential for misuse of robotic technologies, which need to be carefully managed. Addressing these concerns is crucial for ensuring that the benefits of robotics are realized while mitigating potential risks, paving the way for a harmonious coexistence with these advanced machines. Humanoid robots, designed to mimic the human form and capabilities, represent a significant leap in robotics. These machines are crafted to not only look like humans, but also to perform tasks with human-like dexterity and precision. These robots are not just machines, they are sophisticated systems that combine advanced mechanics, artificial intelligence, and sensor technology. Each component works in harmony to create a seamless and efficient robotic experience. Their development marks a significant step towards creating robots that can seamlessly interact with and assist humans in various environments. From offices to homes, these robots are designed to be versatile and adaptable. Boston Dynamics' Atlas and Tesla's Optimus are two prominent examples of humanoid robots pushing the boundaries of what's possible. These robots showcase the cutting-edge advancements in robotics technology. Atlas, known for its impressive agility and dynamic movements, can perform complex tasks like running, jumping, and even backflips. Its ability to navigate challenging terrains and perform acrobatic feats is truly remarkable. Optimus, while still in its early stages of development, is envisioned as a general-purpose robot capable of performing a wide range of tasks, from household chores to industrial work. Its potential applications are vast and varied. These humanoid robots are not just technological marvels, they represent a significant investment in the future of robotics. The research and development behind these robots are paving the way for future innovations. Their development requires overcoming complex engineering challenges, including creating robust and adaptable hardware, developing sophisticated control algorithms, and integrating advanced sensor systems. Each of these elements is crucial for the robot's overall functionality. The progress made in these areas is paving the way for a future where humanoid robots play a significant role in our lives. They could assist in daily tasks, provide companionship, and even support elderly care. The development of humanoid robots also raises important questions about the future of human-robot interaction. How will we coexist with these intelligent machines? As these robots become more sophisticated and capable, it is crucial to consider the ethical implications of their integration into society. This includes discussions on privacy, autonomy, and the moral status of robots. This includes addressing concerns about job displacement, safety, and the potential for misuse of these advanced technologies. Ensuring that these robots are used responsibly is paramount for a harmonious future. Humanoid robots are poised to transform various sectors, offering their unique capabilities to enhance efficiency, improve safety, and provide valuable assistance. In personal assistance, they can help with tasks like elderly care, child care, and household chores, freeing up human time and resources. Their ability to navigate human environments and interact with objects makes them ideal for these roles. In manufacturing, humanoid robots can work alongside human workers, taking on physically demanding or repetitive tasks. This collaboration can improve productivity and reduce workplace injuries. Their adaptability and dexterity allow them to handle a wide range of manufacturing processes, from assembly and welding to quality control and packaging. Healthcare is another area where humanoid robots hold immense potential. They can assist medical professionals with tasks like patient monitoring, medication delivery, and rehabilitation exercises. Their presence can also provide companionship and emotional support to patients, improving their overall well-being. The versatility of humanoid robots extends beyond these specific applications. They can be deployed in hazardous environments such as disaster zones or nuclear power plants to perform tasks that are too dangerous for humans. Their ability to adapt to various situations makes them valuable assets in these challenging scenarios. Section 4. Striving for human-like robots, challenges and breakthroughs. Creating truly human-like robots is a complex endeavor, fraught with challenges that push the boundaries of engineering and computer science. One of the major hurdles is developing robust and adaptable hardware that can replicate the intricate movements and dexterity of the human body. This requires advanced materials, actuators, and sensor systems that can seamlessly integrate and function together. Another significant challenge lies in developing sophisticated artificial intelligence algorithms that can enable robots to perceive, reason, and interact with the world in a human-like manner. This involves creating algorithms that can process vast amounts of data, learn from experience, and adapt to changing environments. Despite these challenges, significant breakthroughs are being made in humanoid robotics. Advances in areas like computer vision, natural language processing, and machine learning are enabling robots to better understand and respond to human commands and interact with their surroundings more effectively. The development of more efficient and powerful actuators is also contributing to the creation of more agile and dynamic humanoid robots. These advancements are paving the way for a future where robots can seamlessly integrate into human environments and assist us in a wide range of tasks. Section 5. Robotic surgeons and healers transforming healthcare. Robotic systems are revolutionizing healthcare, offering unprecedented precision and minimally invasive procedures. These advancements are setting new standards in medical care. Surgical robots like the Da Vinci surgical system provide surgeons with enhanced dexterity and control, allowing them to perform complex operations with greater accuracy and smaller incisions. This technology is transforming the way surgeries are conducted. This leads to reduced patient trauma, faster recovery times, and improved surgical outcomes. Patients can return to their daily lives more quickly and with fewer complications. Rehabilitation robots are assisting patients in regaining motor function after strokes or injuries. These devices are crucial in the recovery process. These robots provide targeted exercises and feedback, helping patients regain strength, coordination, and mobility. The personalized approach enhances the effectiveness of rehabilitation. Robotic exoskeletons are also being used to assist individuals with mobility impairments, enabling them to walk and perform daily activities more independently. This technology is giving people a new lease on life. Drug delivery robots are improving the precision and efficiency of medication administration. They ensure that patients receive the correct dosage at the right time. These robots can navigate through the body to deliver drugs directly to targeted areas, minimizing side effects and maximizing therapeutic efficacy. This precision is vital for effective treatment. This is particularly beneficial for treating conditions like cancer, where targeted drug delivery is crucial. It enhances the effectiveness of treatments and reduces harm to healthy tissues. Robotic systems are also being used to automate laboratory tasks such as sample handling and analysis. This automation is revolutionizing lab work. This increases the speed and efficiency of diagnostic testing, allowing for faster diagnosis and treatment. Quick and accurate results are essential for patient care. Automation also reduces the risk of human error, improving the accuracy and reliability of laboratory results. This ensures that patients receive the best possible care based on precise data. Section 6. Enhanced patient outcomes. The benefits of robotic assistance. Robotic-assisted procedures offer numerous benefits that significantly improve patient outcomes. Minimally invasive surgery enabled by surgical robots results in smaller incisions, reduced blood loss, and less post-operative pain. This translates to faster recovery times, shorter hospital stays, and a quicker return to normal activities for patients. Robotic rehabilitation systems provide patients with personalized and adaptive therapy. These systems can monitor patient progress and adjust the difficulty of exercises accordingly, ensuring optimal therapeutic benefit. The targeted and repetitive nature of robotic rehabilitation can lead to significant improvements in motor function and overall recovery. Robotic drug delivery systems improve the efficacy of medications by delivering them directly to the target site. This minimizes systemic side effects and ensures that the drug reaches the area where it's needed most. Targeted drug delivery can be particularly effective in treating conditions like cancer, where minimizing damage to healthy tissues is crucial. The use of robotic systems in healthcare also improves the efficiency and accuracy of medical procedures. Surgical robots enhance precision and dexterity, reducing the risk of surgical errors. Automated laboratory systems increase the speed and reliability of diagnostic testing, leading to faster and more accurate diagnoses.